who've done the most complex design on Earth. But how do you port your skills and the architectural best practices that you've learned into public cloud? And why is this not really portable as is, right? So the reason things moved to the cloud was on-prem was slow. Provisioning of these services was slow. And if when we started, we had physical, let's say the network infrastructure was governed by Cisco, and similar vendors, and then you had the network virtualization that came, and the private cloud concept that came in, and people built private cloud on-prem, but that was a very hard and long journey. And then you have the public cloud. The thing is that you're losing, one of the things that you're gaining is being faster, but you're losing control. So now when you're in the public cloud, you have no access to the underlying infrastructure, right? You have some knobs exposed which by the native cloud constructs. And when I say the word construct, it means things that are provided, for example, a route table or a VPC or a transit gateway. All of these things are constructs. So they provide you these constructs and say, hey, go build it yourself, right? So there's an architectural gap in here because these constructs are provided to you, but you have to build it yourself. And it lacks a proper multi-cloud network architecture that would help you build and build on the public cloud while consuming the cloud constructs. If we take a step back, and again, this is just to make sure that everybody's on the same page, because sometimes we hear these terms and we want to make sure that when we go into the deep dives later today, we are all on the same page. So if we think from the previous slide, the different architectures we built, how do they map to the conversations that we've had? So when were completely on-prem, so this is where you owned the entire stack, right? From there on, you came into the environments which are referred to as IaaS, infrastructure as a service, where this is mostly in your on-prem cloud as well, private cloud. Some of them had that, and this is what, when you go to Azure, AWS, GCP, and you say, hey, I'm going to go and spin up an instance, right? That is where you're consuming IaaS services. So you have the underlying networking, storage, virtualization is managed by the cloud service provider. So cloud service provider is depicted by CSP. But the blue part is something that you are managing. So you deploy the instance, you manage the operating system, and the application that runs on it. Then you have the option of PaaS, where it's a further reducing the control. So the orange part is now what cloud service provider manages. So you are only coming in and consuming the platform. Let's say you're consuming SQL or something like that, right? So you're just consuming SQL as a platform, but you're not worried about managing its operating system, its uptime, its patching, and all that. And the last is SaaS, which we all aware, where you just go and consume the service and you have no control and responsibility over the application. You just go and consume, like a Office 365 or Salesforce and stuff like that. Now let's go into the cloud deployments and see the different constructs. So you have the public clouds, right? So you have public cloud being provided by major public cloud providers today, AWS, Azure, GCP. It's a shared infrastructure. It's hosted at their private locations, and it's shared tenancy essentially, right? You may have some options to lock down or buy a specific host or dedicated host and stuff like that, depending on the provider. But for the most part, you are in a shared environment, right? Compared to the private cloud where everything was owned by you. And the hybrid cloud definition is a combination of private cloud and public cloud. And going forward, what we're seeing is that the private cloud presence is going to keep shrinking and the public cloud presence is going to keep increasing. So when one of the CIOs I heard, they said that every organization, the basic principle is you reduce your expense and you increase your investment. For me, my on-prem is an expense. So I'm going to reduce the investment I'm doing there, and public cloud is the investment. So I'm going to increase the amount of funds that I'm making available. So that's how the scales are tilting in favor of public cloud going forward, because people see public cloud as investment and on-prem as expense. So now let's talk about the public cloud basics. So the first thing that you need to think about is data center, right? So data center is a data center. It's your data center, or it's a cloud provider's data center. Is basically the same thing. In the cloud provider's data center, they have automated most of the things. Hence, the time to deploy is much faster. You'll hear the concept of region. So these data centers from cloud providers are clustered in different regions. So you will hear, for example, Azure will say US East, East US, East US 2, West US, West US 2. So these are different regions. You have different cloud providers spinning up new data centers in these regions, and each data center has resiliency built into it from a lot of different networking and physical aspects. Then you have the concept of availability zone. So within a region, it's usually not going to be one single physical facility. So a region is usually made up of different facilities. So you may have availability, and which are referred to as availability zones. So you may have availability zone 1, availability zone 2, availability zone 3 within the same region. These availability zones are essentially connected with very fast, high-speed connections. And there's essentially a race for who has the most points of presence, and there are various ways that people the cloud providers are spinning up presence. So some places where they have regions with multiple availability zone. Sometimes they will have regions with single availability zones. Sometimes they have just edges, which are point of presence for people to get into their network, but they don't really have a full-fledged data center there. They may be co-located with some other facility and providing some edge functionalities only and not really hosting. So there's various ways the cloud providers are getting into different regions of the world. And if you look at AWS, Azure, GCP, OCI, all of them have different points of presence and regions around the world. We talked about availability zone. So another key thing about availability zone is that when you go and spin up a resource, you'll say availability zone, let's say 1A or 1B or 1C. So the availability zone 1A for you may not be the availability zone 1A for me. So they randomize it so that not one availability zone is overwhelmed. So within an account or within a subscription, for me, 1A will always refer to the same physical location, but for another account, 1A may be a different availability, a different physical location within the same region. So one of the things that you will see that the public cloud networks are very similar in some ways, but at the same time very different. So you have the same constructs. You still have your servers or instances or switches and routers and firewalls and internet and all these things, but their location has completely changed. So one of the things you'll notice is that when you were on-prem, you had a lot of control over things because you owned the layers. So these layers that I'm showing, you owned them. You controlled how the packet would be routed, right? If you wanted to put a firewall or something, you can easily make sure that the traffic goes there because you own the layer. But now when we are in public cloud, has completely changed because you have no control over the layer. So the world is essentially flat in public clouds. Everything is sitting next to each other. So if you look at a VPC, and we'll look into more of what that means, or you have the instances or virtual machines, and they have some subnets which are basically doing, switching between these instances, and then you have implicit routers which you never see that are providing communication paths between these subnets. And then you have ACLs or port level security, or sometimes you will have firewall rules which are at subnet level. So you have the same thing as you had in on-prem, but on-prem, for example, your servers didn't really had a firewall rule or IPS IDS until it hit the AG layer, right? But things are changing. I mean, you can argue that, for example, things like NSX would allow you to put a firewall in here in a distributed fashion, but then again, that was a journey that public cloud fulfills, right? Now, another thing that you would see, which is very different from on-prem, is that things like internet, right? So internet, if you see from a server perspective, was far away, but now the internet is sitting right next to the application. You know, your VPN, people who would VPN in would come in somewhere here, but now they're coming right into where the instances live, right? There was no need for NAT at this level. NAT used to be somewhere over here, but now NAT is at the same level. So things are being condensed. They're like, coming very, very close to each other, meaning you have no layers, and it becomes very hard for infrastructure people to provide same level of services.